Hello, class. We're about to cover sections 4.8 and 4.9 and possibly 4.10 as well. But let's start off with 4.8, which basically starts on page 463, and it's supposed to be problems 1 through 15 odd, and we will be doing a few of these problems. So I want to start on page 464 with problem number 3. For problem number 3, it says assume that y varies directly as the square of x, and that when x equals 2, y is 12. Determine y when x is 8. So this is the general formula that we use. With the y varies directly as the square of x, this is the direct formula, and we will have x squared as well. Okay, so now we need to find out what k is equal to. So as it says in the directions, x is 2 and y is 12. So we're going to substitute this in to find out what k is equal to. So we substitute in 12 for y, and then x is 2, and that's squared. So we have 12 is equal to k times 4. We divide each side by 4, and k is equal to 3. So now we will rewrite this direct variation to y equals k would be 3. So it'd be y equals 3x squared. Now they tell us to determine y when x is 8. So now we would take this formula and we would substitute in 8 for x. So we have y is equal to 3 times 64. So y is equal to 192. So that is our final answer. Y equals 192. Now the next number we're going to look at is problem number 5. Problem number 5, it says the number of meters d that a skydiver falls before her parachute opens varies directly as the square of the time, t, that she is in the air. A skydiver falls 20 meters in 2 seconds. How far would she fall in 2.5 seconds? Okay, so first thing we would do, we had d is equal to k, and then instead of x, we have t in its place. Okay, so now we're told that a skydiver falls 20 meters in 2 seconds. So D stands for the distance, so D would be 20. And then we would have K times T would be 2 here. So now we're still solving for K. So we have 20 is equal to K times 4. We divide each side by 4, and 5 is equal to K. So now they tell us here, how far would she fall in 2.5 seconds? So we had D is equal to K times, well, actually, is D is equal to 5 times, and then we will substitute in the 2.5 squared. So 5 will replace K, and as a matter of fact, I didn't write out the general new formula. The general new formula is D is equal to 5T squared, because K is 5. Now, when we put this in our calculator here, we will have D is equal to 31.25 meters. Now, I could put that in the calculator real quick so you can actually see it in the calculator. We will have 5 times 2.5 squared. So that gave us the 31.25 meters. All right, the next problem we're going to do is problem number 11. Problem 11, it says determine the x interval over which the function f of x is equal to 1/2 x to the fourth is increasing. So let's put this in our Desmos calculator. We could put y is equal to, now 1/2 we know is 0.5, so we could type in 0.5, and then x, and then we want to take that to the fourth power. Okay, so now we have our graph here. Now they want it over the interval that this graph is increasing. So basically, if we look at this, f of x is increasing Now we look at our x values. When we say it's increasing, that means it's going up as far as y is concerned. So remember, we read graphs from left to right. So going from left to right, we notice the graph is going down. As x increases, the graph is going down from the left side. But then from the right side here, from 0, it starts going up for the x value. So basically, f of x, which is y, is increasing for x is greater than 0. Because here, when x is 0, the graph is flat. The graph starts increasing as x gets larger than 0. So this right here is the final answer for problem number 11. Now, I believe we can go to problem 15, and this will be the last problem on section 4A. It says, how are the graphs of y equals negative 2x cubed and y equals 2x cubed plus 1 different? How are the graphs similar? Okay, so first thing, I want to turn this graph off. And let's type in these equations here. Y is equal to a negative 2x to the third power. Okay, that is the first graph. And then next we will have y is equal to 2x cubed. And then I believe it's plus 1. Okay, so now when we look at this for problem 15, now we notice the green graph is the y equals negative 2x cubed, and then the purple graph is the y equals 2x cubed plus 1. So we could say the graph of y equals negative 2x cubed is decreasing and goes through 0, 0. Now remember, we read the graph from left to right, and if you notice here, as our x values increase, the y values go down. So it's decreasing. And then it also goes through 0, 0, through the origin. Now, whereas y equals 2x cubed plus 1 is increasing. And does not pass through the origin, which we know is 0, 0. And both have a similar S shape. And that's basically it for problem number 15. Now we're going to go over to section 4.9, which is on pages 470 to 471, and it's 1 through 9 odd. Now we're going to go through a few of these problems here, starting with problem number 1. Now problem number 1, it says in exercises 1 through 3, determine the x-intercept of the graphs of each polynomial function using an algebraic approach factoring. Verify your answers using your graphing calculator. So what I want to do, I want to turn these graphs off just in case we may need them later. But number 1, we had f of x is equal to x cubed plus 3x squared plus 2x. Okay, now we want to first factor this. The first thing we could do is take out the greatest common factor, which is x, and that will leave us x squared plus 3x plus 2. Now, we went over all of the factoring properties before, so we know this factors out to be x plus 2 and also x plus 1. So we have x times x plus 2 and x plus 1. Now, when we're trying to find the x-intercepts, the definition of x-intercept is when y is equal to 0. So we'll set f of x equals 0. And then we have 0 is equal to x times x plus 2 times x plus 1. Now we will set all three of these factors equal to 0. So we have x equals 0, x plus 2 equals 0, and x plus 1 equals 0. And then we will solve this. So this is already solved. And then here we'll subtract 2 on both sides, and x is negative 2. Then we will subtract 1 on both sides, and x is negative 1. Okay, so now they wanted us to write this in x-intercept form. So it'll be 0, 0, negative 2, 0, and then finally negative 1, 0. And these are your answers. Now, if we want to prove this using our graph, we could do y is equal to x to the third power plus 3x squared and then we have plus 2x. Okay, now we're looking here to see where the graph hits the x-axis. So we can go here, negative 2, 0, negative 1, 0, and then 0, 0, which is the amounts we have here. Okay, so we did problem number 1. Okay, we'll do problem number 5. Problem number 5, it says consider the function defined by f of x is equal to x to the fourth minus 6x cubed plus 8x squared plus 1. Now, for A, it says use your graphing calculator to sketch the graph of this function. Okay, so we need to put this function in. Now, instead of using f of x, we're going to use y. So we have y is equal to x to the fourth power minus 6x to the third power plus 8x squared and then plus 1. All right. So now we have our graph here. So that's A. Now we look here at B. It says determine the domain of the function. If you look at this function here, there's no x values that cannot be used. So then I'll just make this B because our graph was A. So it'll be all real numbers is the domain. Now C, it says determine the range. Now if you look here at the range, this is the lowest that it could be here when y is a negative 8.915. So you could say the range is y values greater than negative 8.915 according to the graph. Now we come here to D. Use your graphing calculator to estimate the x-intercepts of the function f of x. So what we would do here is hit where the graph hits the x-axis. It's only two places. So basically, we write this as an ordered pair. If we round to two decimal places, it'll be 2.120, and then it'll also be 3.970. Now we go here to E. It says use your graphing calculator to estimate any maximum and or minimum points. Okay, so basically, you basically had two minimum points here. So we'll put there are two minimum points, and then one of them is 0, 1, and the other one is 3.28 if we round to two decimal places, and negative 8.9. I think that 5 was rounded, but it's supposed to be negative 8.91 when you round. So I'm thinking that this was a lot longer. It was 8.9149 or something, and they rounded that to 5. So it should be a negative 8.91. So that's how we get the negative 8.91. And then we have one max point, maximum point. Now, if you look here, this is your maximum point. If we round that to two decimal places, we have approximately 1.22 and then 4.23. And that is the maximum or minimum points. Okay, now, I believe the last problem that we're going to do is problem number 9. Grab up another scrap sheet of paper here. So we look here at problem, let's see if I can get another green sheet. Okay, we look here at problem number 9. It says, consider the following graph of y equals f of x. Okay, let me turn this off. It says 9a. It says as x decreases without bound, the corresponding y values. Okay, so let me type this in here. So we have y is equal to, oh, well, they actually had a graph drawn there. So you would need to look in your textbook at 471, number 9, to look at the actual graph they have. Okay, they tell us as x decreases without bound, the corresponding y values, it'll be increased. Because if you look at that graph on page 471, when x is decreasing, you notice that the y values are going up. They're not going down. As x decreases, y is actually going up. Okay, now we have b. It says, is the function f increasing or decreasing for negative 2? I'm going to write this out. It's less than, x is was greater than negative 2, but less than 2. And it's decreasing. You look at the graph, you look between negative 2 and 2, x is decreasing. I mean, the graph is decreasing. And remember, we read from left to right on the graph. So now C, how many turning points does the curve have? Turning points just mean this here. It means that if you're decreasing, and then you go from decreasing, you stop, and then you go to increasing, then that'll be just one turning point. So if you look at this graph here, it only has one turning point. It's not two turning points, just one. It goes down when we're going from left to right, it goes down and then it goes up. So that is only one turning point. And we're done with 4 and 9. Okay, we're going to do 410 as well. We're going to go to 410, which is from pages 473 to 475. And it's problems 1 through 3 all. Now I'm only going to do one problem here, which is problem number 2. Okay, so now it says here for 2a, and this is on page 474. It says, using the results from 1b, select the equation that best models the percent of 8th, 10th, and 12th graders who admitted to using cigarettes G as a function of the number of years since 1990, which is T. So If we look back here at 1b, we had two equations. We had a quadratic and we had a cubic. Now the quadratic equation was g equals negative 0.04 x squared minus 0.52 x plus 57.33. The cubic was g is equal to 0.006 x cubed minus 0.276 x squared plus 2.004 x plus 51.98. Those were the two formulas that we got from 1b. Now they're asking us which one is the better model since 1990 for 2a. The actual better model was the cubic. So we had g is equal to 0.006 x cubed minus 0.276 x squared plus 2.004 x plus 51.98. This was the best model. And you found out the best model basically by looking at your R values. So now we go here to B. Or as a matter of fact, let me put this in so you all can see this. So what we would do, I guess what I'll do, I'll go back to problem 1 and put in the table so then you can see how this came about. So with the table here, we had 1, 4, 7, 10, 13, 16, 19, 22, but they had 25, but this ended with 26. Now we go to put in these numbers. We have 53.5, 54.6, 57.4, 51.8, 40.8, 35, 31.2, 27, and 18.2. All right, now what we would do is put in the general formula for each one of these. Okay, so for the quadratic, the general formula, we have y is equal to ax squared. Actually, it should be y sub 1. And we got to do the tilde. Hold on, I got to go back here and get this tilde. Hit here, hit the tilde, and it'd be ax1. Okay, now we have that, then we have plus bx1, and then plus c. Okay, now that gave us the quadratic. And as you see here, we rounded to 2 decimal places. Now we would do the cubic. So we have y1, the tilde, and it'll be ax1 cubed, and then minus bx1. Then we would take that to the second power. Well, actually, it's supposed to be plus, not minus. Plus bx1 squared. And then we would have cx, well, plus cx1, and then plus d. All right, so now if we look here, our r squared values, this has a higher r squared value. And we know whichever one, since both of these are positive, whichever one is closest to positive 1 is the better fit. And that's how we came up with the cubic. So I wanted to be sure that you understand how we came up with the cubic value for 2a. Now we go to 2b. What is the practical domain of this function? Now, if you look here, Now we want the cubic only. So if we look here, the practical domain of this function is basically, so let me write this down. The practical domain is the integers. Now remember, domain deals with the x value. Is the integers from 0 to 26. And the reason why it's 0 to 26, if you go back to problem number 1, they show us here, according to the National Institutes of Health, cigarette usage for 8th, 10th, and 12th graders combined for various years from 1991 to 2016. Now, 2016 is the furthest we would go, but this graph is set up for years since 1990. So 1990 would be the 0 year. So that's how we get the 0, and we get the 26 because we don't go past 2016. So that is the practical domain here. Now, the practical range. So we will put the practical range is the real numbers from. Now let's take a look here. Now, we want to look at this practical range. Now remember, we're going from 0 to 26. So since we're going from 0 to 26, the practical range here basically goes from the highest point, which would be basically 60. Yeah, the highest point, which would be basically 60. And then the lowest point, which would be 15. If we look right here on the graph, the lowest point would be 15. So the practical range is the real numbers from 15 to 60. So that would be our y values from 15 to 60. 15 being the lowest value and 60 being the highest value. And in this case also, some of your answers can vary, but it would be some variation between 15 to 60. Okay, now we go here to D. Okay, now with D, it says use the equation in part A to estimate the percent of 8th, 10th, and 12th graders who admitted to using cigarettes in 1987, 2003, and 2020. And which of these estimates do you have the most confidence? Okay, so first of all, 1987, that would mean that X would be -3, because remember, this is years since 1990. So we would be going back in time here. In 2003, X would be 13, and then 2020, X would be 30. Okay, so we would have to do this. So we add T, because we'll replace X with T. T equals -3. So when we put it into our formula that we got from that we gave the answer for A, it would end up giving us approximately, when we change this to a percent, 43.32%. Now, if you basically need me to type that out, I'll do that really quick. Now, I'm not going to do this for each one of them, but I would do this for, well, actually I can. Let me write out that formula that we had. We had y is equal to 0.0006, how many zeros? 2 zeros, x to the third power. Minus 0.276 x squared plus 2.004x plus 51.98. Okay, now what we could do to make this a lot easier for us is hit this wheel here and hit the table. Now that we have this table in here, we could just type in the value. So if you type in -3, you see it has 43 point, we round to 2 decimal places. It'll be 43.32%. Okay, now the next number would be 13. So basically, T equals 13. G of 13 would be approximately 44.57%. And then finally, T is equal to 30. G of 30 would be approximately 25.7%. So basically, I would have the most confidence in 2003 because that is in the range of the data. Because remember, we went from 1990 all the way up to 2016. So 2003 is the only one that's contained within the data. So that's the one that I would have the most confidence in. So that finished up section 410. And if you have any questions, feel free to reach out to me. Have a wonderful day.